Here I'm going to talk about the triple product rule for derivatives. And this is based off of the simple product rule between two functions for derivatives that you would learn in a Calculus 1 type class. And this follows pretty simply from that. It says that the derivative of three functions multiplied together, we'll call them f, g, and h, is equal to f prime times gh plus f times g prime times h plus f times g times h prime. So I'll go ahead and prove it over here, and then we'll do a couple of examples. So first we want to take the derivative of fgh, but then we'll split this into two functions. We'll split it into f being our first function and gh being our second function. But now we want to use the normal product rule that I have in yellow down here. So we'll have f prime times gh plus f times gh prime. But now this right-hand side, we need to apply the product rule again. So we'll have f prime times gh, that's this term right here. And then the right side, we'll have f times g prime h plus gh prime. But now, multiplying this f through both terms, we'll have f prime gh plus f g prime h plus f g h prime, which is exactly what we were looking for here in red. So now that we've proved this, let's look at a couple of examples of where we might use this triple product rule. So first I want to look at the absolute simplest example there is, and that's x cubed, where f, g, and h are all just the function x. So we'll have f prime times gh, but that's just 1 times x, plus f times g prime times h, that's just x times 1 times x, plus x times 1, that's f times g times h prime. But now we have x times x, that's x squared, plus x times x, that's x squared. Same thing for this third term, but that gives us 3x squared. And we know that this is true, that 3x squared is the derivative of x cubed by the power rule. I have a video on the power rule, the product rule, the quotient rule, and the chain rule up on the channel already if you want to go check those out. So now let's look at an example that might be a little bit more complicated. So I want to finish this video off by finding this complicated derivative of the function e to the 2x times sine of x squared times the natural log of 6 times x to the 4th. So let's go ahead and use our triple product rule here. First, what we want to do is take the derivative of e times 2 to the x, but that's going to be 2 times e to the 2x. So this is the derivative of f, where I'll underline f here in yellow. This is f, and then I'll underline g in green. That's the second function here. And then our third function I'll put in blue here. That'll be h. So this yellow bit is the derivative of f. Then we multiply by g and h without taking the derivatives. That's sine of x squared times ln of 6x to the 4th. But now we need to add, where we take the derivative of g and leave f and h alone. So that's going to be e to the 2x times 2x cosine of x squared. That's the derivative of g times the natural log of 6 times x to the 4th. That is h. So this part right here, 2x times cosine of x squared, that is the derivative of g here, which is this part of our triple product rule that we have in red over here. And now we need to add this last part where we have f times g times h prime. F is e to 2 to the x. G is sine of x squared. And now we need to take the derivative of this part in blue, which is just going to be 24 times x to the 3rd all over 6 times x to the 4th. But now this last term simplifies a little bit. This 24x third can be simplified down to just 4, because 24 divided by 6 is 4. And that means that this 6 also goes away, and we're just left with an x on the bottom here, because we had x cubed here and x to the 4th down here. So that's our last term for this triple product rule. And we can simplify this a little bit, maybe by pulling out an e to the 2x, but I think that's enough for now.